Next is Lee-Chatelier's principle. What happens is that suppose here we are having a reaction. Lee-Chatelier principle is applicable for reversible reactions. The very first point is Lee-Chatelier's principle is applicable for the reversible reactions. So what happens is that reversible reactions exhibit equilibrium, and according to Lee-Chatelier principle, when we change the concentration, pressure, temperature, and add some inert material or gas, the reaction what it does due to change in equilibrium, it undoes the changes in equilibrium due to change in the concentration, pressure, temperature, or when you add the inert material or gas. So we will discuss this in detail, what happens when we change the concentration, pressure, temperature, and when we add the inert material or gas. So the very first condition is when we change the concentration, change in concentration. Suppose we are having an equation that is N2 plus 3H2 that gives ammonia, right? So we have to find out that when we change the concentration on either side, what happens to the equilibrium, where it shifts basically. So what I am doing is that I am changing the concentration of N2 and I am increasing it. So due to increase in it, what happens is that the number of moles on the left hand side increases and the tendency of forward reaction increases. So the equilibrium shifts to that direction where number of moles is less, right? So here the equilibrium shifts forward. Next is change in pressure. What happens when we change the pressure of any equation? So let us take an example that is N2O4 that gives 2NO2. So here you are increasing the pressure. Pressure is increased. What happens? Let's see. You know, here any reaction is happening when temperature is constant. So when temperature is constant, you can write that pressure is inversely proportional to the volume. And if pressure is increased, the volume will decrease. And if volume will decrease, the concentration increases, right? So the concentration increases. So equilibrium shifts to that direction where number of moles are less, basically. Here the equation will shift backward as the number of moles of NO2 will increase, and this will lead to the backward reaction changing, right? Next we will discuss another case in this. So here I'm taking an equation that is N2 plus O2 that gives 2NO. So you can see that here 2 moles are there, 1 mole of N2 and 1 mole of O2. So the change in moles, suppose this is delta Ng, the product moles minus the reactant is 0. Change in moles is 0. So what happens is that if you increase the pressure, there will be no affection here. So here no effect is there of increasing pressure. Next is change in temperature. So when you increase the temperature, what happens is that equilibrium shifts in that direction where the energy is absorbed basically. So here I'm taking an example, that is H2 plus I2, so you can understand it clearly. It gives 2 Hi plus 3000 calories. So what happens is that this 3000 calories denotes that this is evolved as the heat, so the temperature is increased overall of the reaction. So what happens is that these 3000 calories is now going to removed from this reaction, and for this reaction should happen in this direction to remove the all the heat, right? So equilibrium shifts to that direction where absorption of heat is there. So for your easiness of understanding, I'm taking another example, that is N2 plus 3H2. And what happens is that this heat is basically removed from it. So the absorption of heat is basically is done in the left hand side. So what happens is that equilibrium will shift forward. Next is addition of inert material, or you can say gas. So basically we are having two conditions, that at constant volume and at constant pressure. So at constant volume, when you add inert material, you are thinking that the volume will increase, but when we take at constant volume condition, so there is no effect, because the volume remains constant and the concentration on both the sides, the product and reactant, remains constant. And when we talk about constant pressure condition, so the equilibrium will shift to that direction where number of moles are more. Let's see why it is happening. When you add the inert material, the volume will increase, right? The volume will increase, and this leads to the concentration decrement. So when you see a reaction, let's suppose A plus B, and it gives 4D, right? So these are 4 moles. So when you increase, when you add the inert material, the volume will increase, and this will lead to the decrement of the whole reaction. And suppose these are 4 moles, so the decrement will be more. Decrement will be 4 times, right? So that is why we are saying that equilibrium will shift where the number of moles are more, right? So here the equilibrium will shift forward.